This is lesson 2.5, completing the square. Our essential question is, how can you solve a quadratic equation by completing the square? So the first one we're going to look at is we're going to use square roots to solve quadratic equations. So it says, what are the solutions of 25 equals x squared plus 14x plus 49? So typically we get quadratics equal to 0 and then we factor. But if you have a situation like this where looking at the right-hand side of the equation, you realize that it's already perfect, it's a perfect square trinomial, it's factorable. So we can solve it this way. So we can say we're going to leave the 25 on the left-hand side, and then we can factor the x squared plus 14x plus 49. So we say what multiplies to 49 and adds to 14. That would be x plus 7 and x plus 7. So this is a perfect square trinomial, which means that both of our factors were the same. So we can write this as x plus 7 squared. Now the reason that this works out nicely is because now we can take the square root of both sides. So on the right-hand side, it just turns into x plus 7. And we know that when we take the square root of a number, we have two answers. So we have a positive and a negative 5. So what this means is we have positive 5 equals x plus 7 and negative 5 equals x plus 7. Then we can subtract 7 from both sides and we get negative 2 and we get negative 12. So sometimes it is not easier to get your quadratic equation equal to 0, but you still have to deal with that number on the other side. So if you notice it's a perfect square, so like 25 is nice. If we square root it, we get a whole number. So those are the times that you would want to use solving with square roots. Okay, our next example is how can you solve 0 equals x squared minus 2x plus 3 by completing the square. Okay, so what we're going to do is we're going to leave the 0 over here. Actually, no, we're not going to leave the 0 over there. So the first step when you're completing the square is we want to, kind of like that previous problem, we want to turn one side into a perfect square trinomial. So we want to make it so that we have something like x plus 7, because then that would turn into x plus 7 squared. So to start out with, you're going to take any constant you have and move it to the other side. So this is going to be, and this is just the way that my brain works, I'm going to write this the other way. So I like to write this as x squared minus 2x, and then equals, we're going to move the 3 to the other side, so negative 3. Okay, so here is how we complete the square. So we are going to, I'm going to put parentheses here. So we are going to add something to both sides of the equation, because then we're balancing, we're keeping it equal. And that something is going to be, let me write with a different color here. So how you get what goes in the box is you take b divided by 2 and you square it. So in this equation, b is negative 2. So remember our ax squared plus bx plus c. So b is negative 2. So if we take half of negative 2, we get negative 1. And if we square that, we get 1. So we're going to put a 1 in both of those boxes. Okay, so the reason that we do this is because now this left-hand side is a perfect square trinomial. So we think what two numbers multiply to positive 1 and add to negative 2. You can also shortcut it and know that it's just going to be half of whatever your b value is. So it would be x minus 1 times x minus 1. And this right-hand side is going to turn into negative 2. So then we have x minus 1 squared equals negative 2. So then we're going to take the square root of both sides. So we're solving using square roots now. 2 is not a perfect square, or if we take the square root of 2, it's not going to give us an integer. But we do know that we can just leave it as a square root. So this is going to be x minus 1 equals, I have to deal with that negative inside the square root though. So this is going to be plus or minus square root of 2 And then I move the negative outside and turn it into an I. So then my final step would be I can add 1 to both sides, and we know we have 2 equations going on here. So this would be 1 plus square root of 2i and 1 minus square root of 2i. Those would be my 2 solutions. And the 1 came from when I moved this -1 to the other side, it became positive. Okay, so that is solving with completing the square. And our last one is we're going to use the idea of completing the square to go from standard form into vertex form. So we have the equation y equals -2x squared plus 10x plus 1. Okay, so the first thing I'm going to do is I'm going to get rid of, just like in the previous problem, I'm going to get rid of the constant and move it to the other side. So this is going to be y minus 1 equals -2. And now here's the thing, before I write the rest of it, I don't want to have a number with the x squared. So if you have a coefficient with the x squared, you need to factor it out. So I'm going to put parentheses here. And if I take a -2 out of 10x, that's going to turn into minus 5x. So that's my first step. Okay, now I'm going to set it up with my plus something on both sides. So I have -2 times x squared minus 5x, plus something. Okay, so now this one's not as nice because our b value is -5. And we know that if we cut -5 in half, it's -2.5, which squared is 6.25. So that's not integers, but it's still okay. So I'm going to put 6.25. Okay, now this is the piece that it's hard to just look at my notes and understand where I got the number here, but I need to explain this next step. So on the previous problem, we just added the same value to both sides, put the same number in both boxes. However, on this one, we have a -2 that is out front of the parentheses. So in order to balance the equations, I have to take the 6.25 and multiply it by -2, and that's going to give me -12.5. So that is the number that goes over here. So again, if you have a coefficient outside, if you have a number outside of your parentheses, you have to remember to multiply by that number when you're balancing your equation. Okay, so now I have y minus 13.5. And then I have -2. And when I go to factor this, remember it's not totally obvious what 2 numbers multiply to 6.25 and add to -5, but we also know the trick that it's just going to be half of our b term. So it's going to be x minus 2.5. Okay, now my final step is to add the 13.5 back over to the other side. So I have -2 times x minus 2.5 squared plus 13.5. So this right here is vertex form, and you can always multiply it back out to make sure it equals. So our maximum value, so our vertex would be at the point 2.5, 13.5. So it says, what is the maximum or minimum value? So I know it's a maximum because of that negative right there. So that tells me it's going to open down. So that's going to give me a maximum value, and my maximum value would be 13.5. So because that's my y value of the vertex. Okay, let me know if you have any questions about completing the square.